Myself, Monica Nancy, the Department of Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. Uh, uh, in this session, we are going to discuss about the Programming 8051 timer. In this Programming 8051 timer, having the accurate, the timers are used whenever there is a accurate time delays, event counting, frequency measurement, pulse generation. We are having the pulse width modulation, no? So pulse generation, the baud rate generation. These are the timers are used. In 8051, we are having the two timers. That is the timer 0 and timer 1. That is the two inbuilt timers. So these timers can operate either as a timers or counters. So timers means it's the count the internal clock pulse, and the counters means it counts the external events. So we are taking a clock. This the seconds will calculate internally so that the minutes will change. Whereas in counters, it's having a digital clock. It having the external events. We are having that 21, 22. So it shows the external counters. So the next one is the 8051 timer overview is in 8051 microcontroller provides two 16-bit counters or timers. That is the timer or counter 0 and the timer or counter 1. These timers are versatile and can perform the multiple tasks. The main application is the generating time delays, counting external events, producing the square waves, and measuring the pulse width. So when we use the timer, the microcontroller uses the internal crystal oscillator. So, for example, if the crystal oscillator is 12 megahertz, so one machine cycle is 1 microsecond. So the timer increments every 1 microsecond. So by counting the machine cycle, the timer creates the accurate delays. So the next one is the event counter functionality. So the event functionality is the counter mode. The timer does not use the internal clock. Instead, it counts the pulses applied externally. So in real life example, we are counting the people entering a hall. In a classroom, we are counting the students count. No, so that is the real life example for event counter functionality, and counting the products on the conveyor belt. So measuring the wheels rotation, how much, how kilometer runs for a, how rotation runs for a 1 kilometer, then counting objects detected by sensors. So each pulse increase the count by one. So the final count is stored in the timer register and it can be displayed by processed by the program. The next one is the timer setup procedure. To use the timer, we follow these steps. First is the load initial level. This is the load initial level. A starting hexadecimal value is loaded to TH value. So TH and TL register. Then it starts the timer. So set the TR bit in the TCON register. The timer counts automatically. The timer increments every machine cycle for one machine cycle. The timer increments the machine cycle. Then the overflow occurs after the timer increments. Then if the overflow occurs, the maximum count is reached. The timer rolls over to 0000H and the set the TF flag. Next, the stop timer, it clears the TR bit. So this sequence repeated whenever a new delay is needed. The next one is the counter functionality. This is the functional, this is the timer setup, that is the clock read. One, we have the T mode resistor and the timer set 0 to 0. Then it will shows the TR bit and the TH1. Okay, next one is the counter functionality. In counter mode, the 8051 counts the external events. That is the T0, that is the T0 and T1 is P3.4 and P3.5. Whenever the pulse arrives at these points, corresponding timer increments the example is traffic monitoring, production counting, speed measurements, sensor event counting. These are the methods. The next one is the external signal through the transmission pin. The notation TX, that is refers to the pin, that is the TX. This is the pin TX, and it refers to the T0 for the timer 0 and the T1 for the timer 1. The external pulse, this is the external pulse. External pulse increments the counter. So the microcontroller can read the count and take the decision based on the result. So the timer register, the several register TH0 and TL0 is have the high and low bytes of timer 0, and the TH1 and TL1 have the high and low bytes of the timer 1, and the T mod is nothing but the configure the timer mode and operation, and the TCON is nothing but the controller controls the timer start stop operation and indicates the overflow. These registers are essential for all timer applications. These registers will all the essential for the timer applications. Next one is the T mode register overview. The T mode stands for the timer mode register. For example, it is an 8-bit register. So you used to configure the timer or counter selection, operation mode, gate control. These are the examples. These are the configuration of the T mode register. So this the lower bit configure the timer T0's mode. If the timer T0 is unused, the bits should be set to the 000. This configures the timer 1 in mode 2 and timer 0 in mode 1. Then the T mode, this gate bit determines whether the timer is controlled only by the software or also by the external hardware. If the gate is 1, timer runs only when internal pin is high. The TR bit is set. Wherever the gate is 0, the timer runs solely under the software control. In most application, gate is set to the 0. Then the gate functionality example is when the gate is 0, the programmer has complete the control over the timer operation. This is the simplest and most common configuration. So this is done by setting or clearing the TR bit to begin or halt the timer. So the set B, the transmission 0, and the start timer 0, the clearing transmission, and the stop timer is 0. The next one is the bit timer or counter mode. The C by T mode means the counter timer selection. The C by T is equals to 0, that is the timer mode that counts the internal machine cycles. And the C by T is 1, that is the counter mode that counts the external pulses, the on T0 by T1 pin. This bit determines the fundamental function of the timer. What is the fundamental function? This is the basic function of the timer. The next one is the CCON register. The TCON register contains the important control bits. The main important one is the TR0 by TR1. That is the timer run bits. One is the start and the 0 is the stop. Then the TF0 by TF1. That is the timer overflow flags set automatically on overflow. This program checks TF to know when the delay is complete. Then the timer 1 mode is 1. The mode is full of 16-bit register. So it is the 0x0000 is very much less than 0x FF. So the timer counts from the overloaded value to FF H. So the maximum count is 65536 is the maximum count. This mode is widely used because it provides the long delays. Next one is the configuring timer mode 1. This is the example. Select timer mode 1 by loading the value of 01H to the T mode register, and they initialize the timer set counting by assigning values to TH and T0. That is, select timer 0 and mode 1 and load the initial count, that is triple FCH. That is the clear TF0, that is the clear overflow flag, and set BTR0 is start timer. This is the timer mode 0 status. This slide illustrates the timer status during the execution. We should observe that the initial value loaded, the counting process is happened, and the overflow occurs when the TF flag is setting. This provides a visual understanding of how much the timer works initially. Then the timer 0 overview is the timer is loaded with the double F, triple F2H is loaded into the timer register TH0 and TL0. Thus, the timer reaches after the overflow, the TF0 becomes 1. So, this indicates that the required delay has elapsed. So, the delay subroutine operation is set BTR0 starts from the timer 0. This timer increments automatically So the overflow occurs, then the TF0 becomes 1, then it wait till the overflow. So we are giving a clear option, clear to set or clear to transmit. It stops the timer, then return to the main program. So these are the step-by-step process of the program or reloading the timer registers. After the one overflow, the timer registers contains the 0000H to generate the same delay again, and the reload TH0 and the TL0. So clear TF0, start the timer again. So these are the process of the how the program will be executed, how the functions will get moved. These are the steps will get will teach clearly about the how the program will get executed. Next, we are going to see about the fifth unit in the next video, and these are the references. Thank you.